Hello everyone and welcome to the class for transportation engineering. I am Professor Kakade VD and we are learning unit number 2, geometric design of highway. Today we are going to deal with the topic of side distance from a geometric design of a highway. So we have learned many things from this chapter. Okay, so here is the side distance. Okay, so what is mean by side distance? So in a simple word, side distance is the length of a road visible ahead to driver at any instant. So why this road, why this particular distance is required? To stop the vehicle, to overpass the vehicle, okay, and the many more for the many more options or for the many more convenience. So in this, the distance along the center line of the road at which driver has a visibility of an object stationary or moving at specified height above the carriageway is known as an sight distance. Okay. So when driver is driving the vehicle and suddenly driver crosses or suddenly met with some kind of the object suddenly arises there or appear there, it must to be visible and it should have a sufficient distance to stop the vehicle or to overpass the vehicle. Okay, there must be headlight of the two vehicle should be visible to each other from apart or some sufficient distance is known as an sight distance. So there are around 5 type of a sight distance which is included for the geometric design of road. In the geometric design of a road, for the convenience and safety, the side distance are considered. Okay, so first one is the stopping or non-passing side distance. Another is the overtaking or passing side distance. Third one is the intermediate side distance. Then lateral side distance, headlight side distance, and etc. So stopping side distance and overtaking side distance are included in the syllabus briefly, but the intermediate side distance, lateral side distance, and headlight side distance not in the that much of an important focus. So here, what is meant by stopping side distance? When there is a suddenly vehicle or object suddenly arises at there should be when driver understand or psychologically prepare that he visible the object and suddenly press the brake, there is a sufficient distance that or the some distance we can say that it generally vehicle take a time to stop. Okay, if suddenly we apply the brake, vehicle does not stop at that particular spot, it stop after the some distance. That distance is known as an side distance. So that sufficient distance should be there for a clearance. This is known as a side distance or stopping side distance. There must be overtaking side distance. That kind of the situation happen when there is a two-way traffic and traffic or the one vehicle is overtaking the another vehicle. That overtaking vehicle should be having a sufficient visibility that another vehicle coming from the another direction should be visible. Okay, that is known as an overtaking or passing side distance. Next one is the intermediate side distance. So this is the 2 SHD, means there is must be a intermediate or the distance between two vehicular clearance is known as intermediate side distance. Later, lateral side distance. What is mean by lateral side distance? Consider one crossing is there. Okay, okay. Consider we are moving from this is the crossing. Okay, and vehicle moving from this direction. Okay, and there is consider one building is at this position. Okay, this is the building. So driver, when driver is not able to see what kind of the vehicle or something else object is coming from this another direction. Okay, sight is blocked up to here. When the sight is clear, when driver is here at this position, then at that particular situation sight is clear. So if this vehicle is here, so suddenly the collision might be happen at the intersection, or something like if there is a too much trees or forest area is there and there is no lateral visibility, in this situation collision might be happen. So that's why lateral side distance, sufficient lateral side distance is required for the safer driving on a road. And then headlight side distance, sometimes in most of time it is of the summit curve, when one vehicle, consider this vehicle is moving from here, there is a, and this vehicle is here. So this these are the headlight. Okay, these headlights are not able to visible at the summit curve. So that's why the collision might be happen, and both vehicle are not able to identify or sense the which vehicle coming or not from the another direction. So that's why these are the most important significance of the side distance and the type, which we are going to learn in the next segment of this video. Okay, so for the side distance, which factors generally affect on the side distance? So total reaction time of the driver, speed of the vehicle, friction between tire and road surface, brake efficiency, gradient of the road. Okay, so only not a side distance affect on the collision or the accident condition. There might be other factor which are affecting on that kind of the accident situation. So which are the factor which affect on the side distance are follows. That is total reaction time of the driver. If driver is alert, okay, some drivers are alert and some are not, they are psychologically might be disturbed. Okay, they are not insufficient knowledge. Okay, that kind of the things are happening here on the reaction time. Okay, when there is a reaction time, okay, there is a one theory which is in your syllabus. That theory is known as PIEV theory. Okay, what is it? PIEV theory. So P stands for perception, I stand for intellection, okay, E stands for emotion, and V stands for violation. Perception, intellection, emotion, and violation. Okay, so total reaction time is depend on this particular theory. So how it depend on the theory? Perception is the time required to receive the sense by eyes or ears towards the brain through the nervous system. So what it happens when if one way, this is the road surface, and consider this is the vehicle. Okay, and this vehicle moving from surface in this direction, suddenly it came across with the some object. Okay, and that object which driver seems, which is sudden reaction. So seeing the object, okay, and processing or transferring that object information to the brain is perception. Another is the intellection, the time required to understand the situation. Okay, ear, eyes, sense, that what we can say organs provide the information to the brain, that sensed by the brain, and then brain try to decode the information that what is the situation at the present condition. So whatever the situation, brain decoded, and when brain decoded the situation, it understand what is the now we could do. So next segment is the emotion time. So in the emotion time, the time during a fear, anger, or other emotional feeling with respect to the situation occurred while driving, and which decides what it decides. It decides what will be the next move. If suddenly there is a anger or emotional part, okay, so driver emotional part is very important for the road safety. From the point of view, the passenger which is sitting in the particular vehicle, or we could say that the passenger or the vehicle moving on the road, or the pedestrian, all of for the all of the passenger or the all of the vehicle, the emotional situation of the driver is important. So emotional situation, what in the which phase of the emotion it is bind by the driver is important. If someone here standing, a driver is suddenly analyze this, the one person is standing and the person which is the enemy of the particular driver, there is some kind of a grudge driver is holding in his heart. In that situation, driver never put the brake, okay. So that kind of the situation might be happen at the particular situation, particular time. So in that situation, what kind of the emotion driver is? When driver is in the fear, driver might move the steering to the another side, it might be another situation. But the driver is in that particular healthy mental condition, and in very calm state of mind, he press the clutch and brake. That is the right emotion which is arises on the brain of the particular driver. And violation on this situation of all of the three, the violation is depend. If a driver from the perception situation or perception point of view, in the perception, driver is not able to understand the or the sense the there is a person or object in front of his vehicle. There is a low eyesight of a driver, and there might be no any other part. If driver in the another intellection part, driver is not able to decode the situation, what is in front of him, it is an illusion, okay, it is a reflection, or it is a actual physical person standing over there. If that kind of this data, if brain is not able to decode, the next move can't be done. Emotion, I already explained you that what kind of the emotion arises in the brain of the driver, that might affect on the violation part. When what is the violation? Actual the data or the actual steps what he do, okay, is known as a violation. In the violation, what could the expected to driver do? He has to press the brake. So this is the PIEV theory, okay. I hope you understand this theory. This is the important. So the total reaction time, okay, factor which depend on the PIEV theory. So it is depend for the different part. The reaction time is different from 0.5 second to the 4 seconds, okay. It is depend on different situation, I already told that. And another is what is the particular situation we have seen. There is a SSD and OSD. Okay, stopping side distance and overtaking side distance. When there is a stopping side distance, there will be 2 seconds. Okay, there will be total reaction time a 2 seconds. Okay, because sorry, it is 2.0. Sorry, my mistake. For the SSD stopping side distance, it is 2.5 seconds, and for the OSD, that is nothing but the overtaking side distance, is 2 seconds. Okay, why it is 2 seconds? In this situation, when driver try to overtake the another vehicle, it is already mentally prepared, so that's why he already know that there will be obstruction, or there will be another vehicle coming from the another side. Okay, so first factor is a total reaction time. It might be 2 seconds or 2.5 seconds, whatever it is. Speed of the vehicle. What is the speed of vehicle? V is important. If speed of vehicle is speed of vehicle is too high, in that situation side distance required is less, or side distance is available very less. If speed of vehicle is low or less, in that situation side distance required is more, or side distance available is more. Friction between tire surface and road surface. What happened in a side distance? Why we required side distance? If the vehicle stops at the suddenly, or on the spot when there is a brake apply, there will be no much more side distance required. But in the India, there is no that kind of situation happen, because there are too many factors which affect on the particular situation. Consider that there is a rainy season or a snowfall area is there, and you suddenly apply the brake. What will happen? There will be friction apply in the road surface and tire surface, and vehicle might be dragged for the some distance. If we consider these two are the main point, when at this situation, at this area, or that this spot, vehicle suddenly apply the brake, so it applies the brake, it might be drag at the some distance. Up to this distance. Consider when this distance apply, so this is known as a skid. This is known as a skid. So the friction between tire and road also important. If there is a no lubricating action at there is a no oil, no water, no snow at there will be more friction, and this distance will be reduces. If consider the smooth surface is there and tire also old, that might be increases that drag distance or skid distance. Brake efficiency. If there is a sudden apply brake and vehicle, the application of brake is sudden. We call this India as a urgent brake. So when we consider as it 100%, but it is sometimes is not 100%. Gradient of the road. Consider this is the so suddenly brake applies, and that situation there is 100% or 100% brakes we consider, and the gradient of the road. Consider this is the descending gradient. And the vehicle are moving from this. If all these things are we apply brake suddenly, there is a less reaction time is there, speed of vehicle is low, but due to the gradient, if you apply the brakes, there is a more chances of the collision. So that's why on the descending gradient, there is a more SSD or side distance required than the ascending gradient. So these were the factors which affect on the sight distance. Okay, so we are now dealing with the first sight distance, which is nothing but the stopping or non-passing sight distance. Okay, we called it as SSD, stopping sight distance. Okay, so in the stopping, what is mean by stopping sight distance? So the clear distance ahead needed by the driver to bring his vehicle to the stop before meeting stationary object or the moving object is known as an stopping or non-passing sight distance. Okay, so it is considered as it is the distance which is required for the driver, okay, to make the vehicle at stationary position, okay, to make the vehicle stop. That distance is known as an stopping sight distance. So here in the figure you could able to see there is a one summit curve, okay, or there is no curve, or there is a plain ground or summit curve, and this vehicle is moving like this in this direction. Okay, in this direction vehicle is moving and there is a one object. So in this particular stopping sight distance we consider object height is minimum object height is 0.15 centimeter. Okay, okay, getting it? We are considering 15 centimeter 15 centimeter as the height of object, 0.15 meter. Okay, and the height of eyesight of the driver is 1.22 meter. Okay, 1.22 meter. So in that here, if it suddenly if driver apply the brake, it required that much of the distance to stop the vehicle or to avoid the collision. Okay, not only stopping, it is for avoid the collision. So that's why it is here in the definition it told that meeting a stationary object. Okay, so SSD, the minimum sight distance available on the highway, it is by the spot having a sufficient length to enable driver to stop the vehicle driving at the design speed safely without collision. So I have already explained in the previous slide, without collision, okay, for sufficient length required, okay, at the design speed. So that kind of the point we have discussed in the previous slide also. And on which factor stopping sight distances depend. Here it is here the mention in the slide, feature of the road ahead. What kind of the feature ahead? It means that there is a summit curve, valley curve, there is a crowded area, there is a forest. What kind of the feature of a road ahead? It might be the smooth surface of the road, etc. and etc. Height of the driver is considered as 1.2 meter and height of the object above the road surface considered as 0.15 meter. Okay. These are the factors which depend affect on the SSD which we discussed. Okay. Analysis of SSD. How to analysis SSD? How to find out how much distance which required, okay, which required to stop the vehicle. Okay, so the whole stopping sight distance is divided into the two parts, which is the lag distance and another is the brake distance. So what is meant by lag distance? The distance traveled during the reaction time. Suddenly PIEV theory, the PIEV theory which took the time, this is known as a lag distance. It means that driver sees the object, the data sent to the brain what are the he thinking, process the data, and at the last he applies the brake or whatever he take the action, that all the things are happen in this lag distance. While you are thinking, the vehicle is still moving. Okay, vehicle still moving, so that's why this distance travel during this all the process. Okay, and then you apply the brake, and when you apply the brake, suddenly the vehicle never stops at the spots, at the particular spot when you apply the brake. So that's why the some distance it travel, that traveling distance is known as an braking distance. So lag distance, it is the distance vehicle travel during the reaction time. So V consider as the design speed, which is in the meter per second. T is the total reaction time, which is in the second. So lag distance is the V into T, small v meter per second. Okay, when we convert lag distance, okay, into the meter or kilometer, the lag distance will be 0.278 capital V into T. Capital V indicates the kilometer per hour unit. Okay, and here the reaction time is taken as a 2.5 second. Why in this situation reaction time taken as 2.5 second? Because the driver is not aware of that kind of the situation. It is not already alert. Okay, in the next, total stopping side distance divided into two distance, which is lag distance and braking distance. Lag distance is the all the process reaction time distance. In this braking distance, when you apply brake, the vehicle travels some distance, that distance is known as a braking distance. So it is the distance traveled by the vehicle after the application of the brake. Okay, after application of the brake, that distance also known as an skid. Okay, this also known as an skid. There is a no rotational moment of the wheel of the vehicle, but still there is a longitudinal movement of the vehicle. Okay, it's known as a skid. For a level road, this is obtained by equating the work done in stopping the vehicle and kinetic energy of the vehicle. So the braking distance is V square by 2gf. Okay, V is the velocity of the vehicle in a meter per second. G is the acceleration due to gravity. F is the frictional coefficient. What is the friction coefficient of the particular road? Because while traveling on the road, there is a material which affect on the friction coefficient. Okay, why? If you are traveling from the cement concrete road, which is already smooth road, okay, so that's why the braking distance might be increased. If you are traveling on the thin bitumen surface road, so the reaction time, or the you can say the braking distance time, will be raised because the friction coefficient is more. Okay, when the friction coefficient is more, braking distance is less. If friction coefficient is less, braking distance is more. So SSD, stopping side distance, lag distance per brake distance. So the formula is 0.278 V into T, E square by 2G F. Okay, so here you could see, when traffic is a two-way traffic in a single road, SSD become 2 into SSD. But then that kind of situation, SSD will become 2 into normal situation SSD. In one-way traffic with a single lane, more lane, or one-way traffic with a more that single lane, minimum SSD equal to SSD. Okay. So I hope you understand this topic clearly and thoroughly. So thank you for watching this video, and we will meet in the next video.